Well, welcome again to another Monday Mornings with Masterwall with Grant and Brian. I am Brian.
I am Grant.
We are here to bring you education, entertainment, and engagement. As always, feel free to email us at grantsmithwick@masterwall.com or brianconroy@masterwall.com for questions, concerns, comments, or topics that you want to talk about. Today, we are happy to have Craig Wetmore with us. He is with York Flashing. Give a little bit of background. He's active in construction community at large. He's involved with CSI, the IIBEC, RENA, ASTM, and ABA. He's a past president of Maine CSI. He serves on many other board and things. Specifically, one of them I thought was interesting was flashing and terminations. He performs AIA sessions all throughout the United States, specifically regards to through-wall flashings, compatibility, and air barrier and insulation products. Wonder why we have him on the show. He has also developed, and we should get into some of that later on, some new products to solve issues that are encountering during, as far as the drainage part of the envelope. And so welcome, Craig. I'll start off by throwing out a general question of how you got here to where you are now with flashings, with York Flashing specific, and walk that into, if you don't mind, three things, the biggest problems that you see, and the 3Ds. I know that we've got a PowerPoint, but I'm going to stop my screen share, just have you comment on some of that stuff as we discuss this and go from there. So welcome, Craig.
Well, folks, thank you so much for having me this morning. Always love talking flashings. I grew up in construction. My dad was a contractor. He also owned a lumber yard up in northern Maine. I currently live just outside of Portland, Maine. So we got a real scorcher here today. It should hit 70. So it's for the rest of you, that's the nighttime low, but for us, that's a pretty good day. So I've been in the building industry ever since I could remember. Got out of college, went into hardware distribution, had the opportunity to come over to the manufacturing side. And when I took this job, my father told me, he goes, "Boy, you're not that smart." He goes, "If you're smart," he goes, "you're going to go out and listen to the people who work with the products every day. Have no ego, just go listen to them, learn from them, and see what we can do better." And when I had the opportunity to come to York Flashings, it was perfect time right during the recession, right before the recession. So we got in here. We only have a couple of products that we had 10 years ago. Everything else has been discontinued. We've redesigned everything because of what is going on with the industry, with air barriers, with insulations. Everything's changing in the wall and energy codes, the whole 9 yards. So we're always looking to learn from each other, how to partner with with other companies. And again, thank you so much for having me on today. And I just really like flashings. It's sort of sad, but this is, I mean, I've ruined my kids. That my 18-year-old graduated yesterday, but I remember when he was 11 going, "Hey Dad, look, that's that fluorescence." And I'm like, "Oh, wow. That's bad. That's bad. The poor kid's going to have a long life." But so that's a little bit about me. We're going to get into, did you want to start with the 3Ds, Brian?
Yeah, do the 3Ds and the three biggest problems, because I think that's one of those things that we see. Like I say in the presentations I give, I can't talk about flashings and penetrations enough. And I think these three things, the three and the three, kind of tie into that as a broad picture, and we can kind of dig down from there.
Absolutely. So a couple of my favorite speakers, folks, building science guys that I love listening to, John Straub and Joe Stiebrick, and I'm sure everybody's heard them before. John gives a PG version. Joe gives the rated R version. You can't have children listen in on all of his presentations. But John's presentation, and he hit it right on the head. He said the three biggest problems with buildings are water, water, and water. And, I always quote Joe with the WAVT, so WAVT. It's the control layers. It's water is first, air is second, vapor is third, and then thermal. And nobody has ever called you up saying, "Oh my God, my building's leaking air."
Mm-hmm.
But if it's leaking water, it's a huge issue. Joe just had a great paper that he put out about, it's about the structure. First, the building can't fall down. Second, it can't catch on fire. And then third, it's all about water. Mm-hmm. because all of our building owners know that buildings cannot leak, right? It just, they can't leak. Everything else is secondary to that. If it's leaking water, you're going to rot your building out. So that's really, to me, the biggest issue in buildings is we have to take care of the water and make sure that we get it back outside of the building.
Now you mentioned the 3Ds, and
Yep.
I thought that was great. What's the 3Ds?
So the 3Ds is deflect. So that's our cladding systems. That's how we put our buildings together. So we have to deflect water away from the building. Every building has issues, right? There's no such thing as the perfect system. I always love, because I grew up in a masonry background, so I talk brick a lot. But the owner will be like, "Oh no, that's a brick wall. It doesn't leak." No, they will leak eventually. And my dad, when I worked for him, I thought he was teasing me back then, but he always said, "Do you know where buildings leak?" And I'm like, "No." He goes, "Where we cut holes in them. That's usually where they leak." Yeah. I watched a presentation of one of the big engineering groups down in Texas, and they said, "We think we've built the perfect building. There's an entry door in the front and an exit door in the back and no windows." And I was like, "Oh my God, they got it. They got it. There's no windows. That building's probably not going to leak as much." Yeah. So all, caulkings go bad, sealants go bad, that sort of stuff. There's movement. So we have to be able to understand that there will be water in this system. So we have to drain the water. Mm-hmm. And no matter what type of system, as you see on the screen, if you're doing EIFS, that's why we have the caulk running down. So you have paths, you have water paths to get out, whether it's masonry, veneer, lap siding, open joint panel, all the different systems. Water will get in, and we have to make sure that we have a robust air barrier back there, a good flashing system back there to make sure that the water gets out. Yeah. And the big thing for me if you're looking at through wall flashings, so if you think about fishing's to me is always catch and release. And that's exactly what your flashing should be. It's supposed to catch the water and it's supposed to exhaust it to the exterior. Yeah. And one of the things I go through a lot of job sites and we catch a lot of water, but we're not that great at getting rid of it. And the longer you let it sit there, the bigger the problem's going to be. Yeah, one of the things I think that was interesting that you said, and I think is one of the things that most of us, especially, again, one of these things for the education part, I think is valuable. This is the product reps, whether it's at manufacturer level or distribution level. You had said last week when we were talking, no one comes to work and says, "I'm here today, make sure this wall leaks," right? Like that's not the intent of anybody. Like, "Oh, let me damage this house as much as I can, or this hotel as much as I can." Going to that with the expectations, what do you see? I thought it was interesting when we talk about expectations, whether building owners, construction managers, GCs, architects, whatever it might be, there is a difference in expectations, right? You had mentioned 4 specific kind of things, something like a fast food restaurant, hotels, residential home, or universities. I mean, those are the 4 you put into that. Those kind of expectation levels definitely change. Talk a little bit about that. Yeah, it's to me, I'll have people laugh at me, and there's a few folks that we were talking to early on before this started, who if I say all flashings are good flashings, they would definitely laugh at me because these are great folks who've been in the field for a long time. But if you're doing a fast food restaurant that you expect it to have a 10-year lifespan, you don't need to put the same flashing in as you would for a university that expects this building to go 200 plus years. There are flashings. Unfortunately, there's a lot of flashings that have a 10 to 20-year lifespan. And I don't know any of us who want to put up a wall that are going to be willing to say it's only 10 or 20 years. Mm-hmm. So it depends on the type of building. If you're doing a building, you're doing a McDonald's, something like that, where they're going to change the cladding every few years, you can use one of those shorter term claddings. But where we run into it a lot is the value engineering of saying, we can put a cheap flashing system in, but how much does it cost to repair that cheap flashing system? What is the life cycle costs of this building? And when think about I'm just going to say a brick building right now because I have a lot of experience with that. Mm-hmm. But how much do you think it costs to replace 1 foot of flashing? Now you're going to show up, do the whole building, right? You're going to do everything. Yeah. But 1 lineal foot, costs $300 to $400 a foot. And I was presenting in Minneapolis, and this guy got up and said I was full of bull something. You told me to clean it up because I tend to speak my mind. And I said, well, you know, I've talked to a lot of people. He goes, that's at ground level. Because if I'm scaffolding 20 stories, he goes, there's a huge cost to it. He goes, so every floor level that you go up, multiply it by the floor level. So it's $300 to $400 a foot. You do it by floor level, it gets really, really expensive. I was down in Alpharetta, Georgia several years ago, hanging out with a forensic engineer. And if you guys hang out with forensic engineers, they're really easy to, they don't have a lot of friends, so they're very friendly. They like
That's
welcome the friendship. So I'm teasing if anybody on.
That's right. Yeah. Let make sure that anybody on there, let you chime in here.
But he brought me into this job, and it was a typical office building, right? It's the one that you see, it's a ribbon window with brick, 4 stories high. It's off of every highway in America. The building was sold as a distressed building. The new owner wanted to redo all the flashings. So make a long story bearable, they wanted to do it by not bringing the flashing out to the leading edge. We're not trying to make this too complicated. When we say through wall flashing, we're not hiding anything. It's supposed to go through the wall. I mean, we put it in the name.
That's right. That's right.
But to fix this building was $350,000. They wanted to leave the drip edges, that sort of stuff out, which would have been another $50,000. And it would have perpetuated the fail, right? It would have continued to fail. So we convinced the building owner to do it right. And the really sad part is they shared with us that originally all they did is they left the flashing short. And they didn't use the right accessories with it. This building was sold as a distressed building after 11 years, cost $400,000 to fix. They only used $1,800 worth of flashing originally, and they missed it, but they missed it by that much, right? They almost had it right. So, you know, what we try to do is just share with everybody whatever we can, because we don't want that situation to happen. Nobody wants a leaking building. Nobody wants the issues.
But that goes to the point of what we talked about. Okay, now we can dive into some of this as far as the compatibility, because I think, you know, one of the biggest threads that we've talked about throughout all these shows, and I just keep talking about all over the place, is the compatibility. Because if you're doing something small, if somebody's out there doing a fast food restaurant and they say, oh, I can save you money on the flashings and the terminations and the caulk and this and that. Okay, maybe the material is going to work with whatever the other material is that they're going against, but you don't know it. And there was a reason why the architect put into a spec, which we get into in a few weeks from now, when it comes to specifications based on the research that they've done and people talking to you as a consultant or to us to say, okay, what's compatible with Masterwall, and is Masterwall, let's say, compatible with York's flashing, right? Like we'll get into that when it comes to, I love the 304 that you have for the stainless steel flashing, but compatibility, dive into that again. You talked 3 specific areas, working together as an overall thing, but chemically and adhesion were the 2 pieces that you had talked about. And also, let me preface this. I'm going to show another slide. I'm hoping it works. If something happens, I just want everybody to be aware of. Hopefully, if I get kicked off for some reason, it will keep going because there's other hosts, because it looked like it slowed up. But I want to show this comparable chart while you start talking about compatibility. So go ahead.
Sure. So when you speak to a manufacturer and you say, are they compatible? What we're looking at is, will one destroy the other, or will one cause the other one to fail? And that's where, you know, we can't guess anymore. It used to be pretty simple to do a wall, right? We weren't putting our insulation outboard of the wall. The air barriers weren't involved. There's a lot of stuff going in that wall, from sealants to insulation, air barriers, flashings, transition membranes. So a lot of things, and they all have to play well together. And that's where, you know, we want to, and I'm part of the Flashings and Terminations Committee at the Air Barrier Association, and we've done a lot of work there to put charts like this together to work on compatibility, to raise the awareness of chemical compatibility, because some stuff just will not work well together.
Yeah.
Perfect example, when I started at York, our #1 selling item was asphaltic copper fabric flashing. That is compatible with not one air barrier or insulations out there, because it's coated in a bond breaker, which means the air barrier cannot make an airtight seal. And by the way, the labs are liquid air barriers. They're not types of dogs. So
that's right. For those who need to know that.
Yeah. So I've had a lot of people ask over the years, but it was really a great group of people. And what we try to do with this chart is just make sure that people are asking for letters of compatibility. Uh, Brian, Grant, I'm sure you guys write letters of compatibility all the time, and that's so cool because you're making sure you're working with the other manufacturers to make sure that the building goes together correctly.
Yeah.
There are companies out there who will stall, will do that sort of stuff. If you're listening to this as a architect or a specifier, find another manufacturer. I can guarantee you'll get the letter pretty quick.
Yeah.
We all work together. We all want this to work together, and we want to make sure that chemically everything goes together well. I heard about a case in Kentucky right now that they're actually suing the architectural firm for putting incompatible materials together. It's the first one that I've heard of in the country, and knock on wood, hopefully it doesn't go through because lawyers are really good at the domino effect.
Mm-hmm.
They get one and they go after them all. So this is very important. You should always field test to make sure products go together. Huge fan of mock-ups. But the help from the manufacturers is huge, and we have to be of value to the folks there.
Yeah.
But when we talk chemical compatibility, we're really talking the architectural community, because when I talk compatibility to a contractor, it's adhesively compatible. Dude, does this stick to that?
Yes.
Right.
Yes.
I'm trying to put these two things together, and yours is peeling off.
Yep. I did it yesterday. It's sticking fine. No problem. Right. We're good to go.
So, Brian, do you have that slide just to show folks,
Yeah.
Sort of what we're talking about there, and adhesively compatible? And the reason that I brought up chemical compatibility first is a lot of people just say, oh, it's just chemical. But it's not, because the folks in the field have a very hard job, and we have to make sure that these materials stick to each other.
That's right. And I love this detail. I mean, this to me is what we see a lot of times, right? When we're out there doing whatever we do with stucco or EIFS at the top of something where there's stone or brick, like in this case underneath it. I mean, it really is. What does this look like? Because this is where we know there's going to be issues.
Right. And one of the things about this, and one of the things that we always talk about, is you got two different systems, two different types of air barrier systems coming together. You have to make sure that, that you get a letter that those two systems can touch. If they cannot, which most of the time they cannot, you need a transition membrane. And transition membranes are super important. And one of the things about transition membranes, you always want it tested both ways.
Mm-hmm.
Because one trade shows up before the other, that sort of stuff. You never know how the sequencing is going to go. So can you put it on top? Does it adhere to that air barrier? And does that air barrier adhere to it?
Mm-hmm.
I'm glad we have video, because I'm very French and I talk with my hands. So finally, webinars are really tough on me. So some of the stuff that we do, and this is just a test that you see up on the screen that our company does with, this is a air barrier manufacturer that we tested with. And what you'll see is certain materials stick very well, other materials do not. And the big thing is a lot of the polyethylene products that have a polyethylene facer, and that can be your rubberized asphalts. We do non-asphaltic copper fabric flashing that has a polyethylene facer on it. Very, very difficult for sealants to adhere to, for air barriers to adhere to. There is a reason that when the caulking tube, the nozzle of the caulking tube is made out of polyethylene.
Yeah.
It's because it's really tough to stick to. So we want to make sure that we have a good working surface, and we want you, when you're looking at stuff, think of adhesive compatibility, because it's super important of tying all these systems together in the field that they can stick well to each other.
So 10 minutes left, and I want to make sure that we hit on a couple of things here. Again, if there's any questions, raise your hand or type a chat. Grant, I know you'll chime in when you need to chime in and want to chime in. But let's go into windows and transitions, windows, terminations into windows, but specifically maybe talking about sill pan, what your thought is on sill pan flashings. And then we can tie that right into kind of the air seal piece that you were talking to me about, the new product that you guys have.
Yeah, so to me, sill pan flashings are super important. Most curtain wall has sill pans built into them. Mm-hmm. But when you're looking at flanged windows, you're looking at some storefront systems, having that back leg, Dr. Joe Stiebrick always talks about, you want to save cash, flash. Well, sill pans are very, very simple, but they almost always get value engineered out. And the reason being is they're almost all sheet metal. So you have to measure it all out, send it into the sheet metal shop. Sheet metal shop sends you back a drawing, you sign off on it, you wait 1 to 2 weeks to get them. And then you still have about a 20% scrap rate.
Right.
There are other ways to do it, but what Joe wants is that back leg.
Yeah.
Right. So most of us do window and door tape all the way around the window, but you need that back leg to keep that water from going in. Remember what my dad said, water gets in where we cut holes.
That's right.
Well, sealants go bad eventually. And when that water gets into your window system and gets down to the base of the base flashing, if it has the opportunity to go inside, it will.
Yeah.
Right. So we need to make sure that that water goes outside. There's sheet metal system, or there's sheet metal that's all custom. There's some plastic systems out there that I recommend. But what we found with the self-adhering stainless steel, you just take a roll, you fold it up. It's just a super easy way to do it. We did a 2,800 square foot house in a couple of hours, and it was $70 worth of material.
Yeah.
So every door, every window had a sill pan in it. You tie your flashings into your window and door flashings into that. But it's super, super important that we catch the water and we release it to the exterior, that we don't give it the opportunity to go inside.
Yeah. And I know Dennis, our technical guy, who is phenomenal. Thank you, Dennis, for all you do, has been working with you a little bit on making sure that we have that compatibility letter already done, that we know that there's a joint sort of thing going on as far as that product of the York 304 stainless steel flashing, so that it's putting us right over top of that. Everything is done, compatible and finished. Making it a lot easier for people to, again, cost savings, definitely, but making sure the quality is there as well at the same time. Okay, so with windows, we know that, yes, there's a hole in the wall. That's where things are going to happen. One of the ugly, I think you had an image in here. I'll find it here. But specifically talking about the air seal, because I do think that it's a really ingenious thing of what you were doing, right? This is kind of the overall picture of what would be, okay, this looks fine. It's kind of ugly. I've never been a fan of this kind of a detail, because that pan flashing, though it's going to do a great job, you're still going to see this metal stuff on the outside. And okay, you have to make sure, like you said, coordination in this case. But go ahead to your air seal piece.
Yeah. So if we could leave it on this picture just for a second.
Sure.
What you have here is the only way to do it right now. Right. It's the best way to do it. You have the best detail you can possibly have. But it's always been a pain, because number one, you have a thermal break. So you have that thermal break running in there. Also, you cannot dry your building in until you put so here's the dilemma. You want to dry your building in immediately, but in that detail, how do you get your cladding underneath that metal? It makes it super, super difficult to install. So if they're going to install the window first to dry it in, then your cladding installers are going to have a hard time getting that underneath. If they're going to put the cladding up first, that means somebody has to go and tape up all the windows. And to put that system in, basically you're poking holes in the air barrier, because all around the window is done, and you have to screw your metal flashing in. So a great consultant came up to me one day and he said, "I'm just tired of nobody listening." He goes, "I think we have a great idea that'll save a lot of time, a lot of heartache for people." And he developed a product called AirSeal. And as my father said, "You're not that smart, boy. Listen to other people, people who know what they're doing." And so it's taken about 2.5 years to develop the product and get everything right. But what it is just a very simple receiver and clip. And if we can click on that next slide right there.
Sit on this one or this one? I think I put another one in here.
No, just one down, the installation one. So what you do is you just put your receiver in, and you go ahead, you do all of your cladding, you do everything else, and when you're ready, so you install your fenestration, you install your cladding, and then you put the piece of metal flashing that goes to the exterior of the cladding, put it into the receiver, clip it in, you're all done.
Yeah.
So all of the damage and stuff that happens on the job site, because you're trying to work around that piece of metal, the agony that each installer has to have trying to work around that system, And the really sad part about that system is what happens a lot of times is they'll install the window and then they'll install the cladding, and then they will go and they will cut the primary seal to
Yeah.
the window, and they'll shove the metal in and they'll caulk over the top of it. But what that did is you no longer have a continuous air barrier system.
Yeah.
So if you cut that primary seal right there and shove a piece of metal in, the air is coming up from underneath. So this allows your primary seal to stay good, and makes it very simple on all of the trades. The other cool part about this, if that metal ever gets damaged, you don't have to take your window out to fix to fix the metal.
That's huge. I mean, I think there are two things with that. That's great in the repair part of it. And like you said, the air, right? The air is what's bringing moisture. It's not so much the air that's the issue.
Mm-hmm.
It's the moisture that the air is bringing with it as it sucks it all in.
Exactly.
Again, water, 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 the three biggest problems in all this kind of stuff of fast flashing and penetrations is the water part of it. And so we want to make sure that we're controlling the air so it doesn't bring the water through and in. One of the things that was asked, and I know this is going back real quick, but I want to hit it in this 11 o'clock hour piece of how doing the peel and stick, the back leg on that termination piece. I don't know if there was a spot here that showed exactly when you're doing that in the creating the sill pan with that.
Yep.
But how would you explain and describe creating that back leg with a peel and stick?
Okay, so here's the deal, that can be done with a flexible stainless steel. And the reason being is it's actually a sheet of stainless steel. So you get it, you fold it down, you crease it real well. All the other peel and stick flashings are polyethylene, cross-laminated polyethylene facers. And even the aluminum ones, they're not actually a sheet of aluminum, they just flecked aluminum on it. You've seen it before, potato chip bag.
Mm-hmm.
You open it up and it's silver on the inside. That's what they're putting on there. So you can't hold that and expect that to stay up. Rubberized asphalt.
Hey, how are you?
Go ahead. We're good.
Yep. So regular peel and stick flashings have to be supported. They cannot span a gap greater than 1/4 of an inch. And when you look at that, that's not supported for the entire window length. And again, there's plastic pan flashings. There's different flashings that you can use for sill pans, but when you're going to use a self-adhering flashing, you need one that is a metal that can hold its shape.
Yeah. And I've said, I mean, there was one I mentioned to you, I know, a job where it was at the termination part. And unfortunately we hardly ever see, right, framers and the foundation not line up. That does never happen. But in the cases rarely that it happens, that they don't line up the sill plate to the foundation, in this case, the foundation was in about 1.5 to 2 inches from where the sill plate hung over based on where they wanted the walls to be. And so they needed something to kind of go around that piece. And in this case, that flexible stainless steel, the York 304 9.5 inch or 9 inch would have been great for them to do that because it's going to maintain that shape. And I think that answers that question of saying, hey, you're going to be able to do this because you can bend it up and it's going to maintain that shape, put the window in and kind of run from there for sure. All right, so we got a minute left, but to hit that air seal again, that piece, and I want to show this. I want to show this again. I think this is it is a big game changer of, hey, this is what we can go ahead and start looking at. One of the questions out there was, is the rigid insulation in the detail a custom cut piece? So is this a custom cut piece here? I'm assuming is what he was looking at. In our case, I would imagine for an EIFS application, this wouldn't need to be here because our EIFS would come up and butt up against this.
Right.
Here, it's just, I guess, a custom cut right on the field before you're putting that metal flashing over top of it, correct?
Correct.
Yeah.
No,
So great detail for sure. Great product. Craig, we're going to stay on for sure like we normally do. I'm going to stop this recording part. I appreciate your time. Thank you for Grant. I don't know if you have anything that you want to say specifically at the end here. We'll roll this part out, but everybody, again, feel free to stay on afterwards. Grant, did you want to say something?
Oh, Craig, thanks for coming on. I know I didn't ask a lot of questions today. I was just going to note at the beginning when you talked about that perfect building with a front door and a back door, they probably forgot the cat flashing. Just kidding.
That's right. That's right.
No, I don't have anything else. I appreciate the info. It's a good, simple presentation, and appreciate you sharing with us, Craig.
Yeah.
Thank you, Grant.
So, hey, everybody, next week is Clark Dietrich. Chris Little is going to be on. So we'll come back again for that. Look for the invites. We'll come there. Appreciate it. Have a great week, everybody.